Welcome back, students, to today's session. Today, we'll be dealing with the topic measurement of length. The first method is parallax method. According to this method, when any object is seen from two different positions, there is a change in the position of the object with respect to the background. This phenomenon is termed as parallax, and the distance between two positions of observation is called the basis. For example, suppose you are holding a pencil against a wall. Observe the shadow of the pencil with each of your eyes closing the other one. The distance between these two positions of the pencil can be called as the basis. Considering the measurement of large distances using the same method of parallax. Here, from the figure, let us suppose that S is a distant object, for example, any planet, and A and B, capital A and B, are two different positions on the earth from which we are observing this planet S. The distance between A and B can be called as the basis, and it can be marked by small letter b. Since S is at a very large distance from the point of observation, we can see that AS will be approximately equivalent to BS. Let this distance be equivalent to capital D. And there will be an angle subtended by the lines AS and BS. This angle is marked as theta, which is known as the parallactic angle. So using this method, we are going to determine the distance of a planet from Earth. So let us assume S is a planet which is at a distance capital D from the Earth, and A and B are the 2 points of observation from the Earth, and the distance AB is equivalent to small b. And we had seen small b is very much lesser compared to capital D, and angle theta will be very small. So AB can be considered as the arc of a circle whose center is at the point S, having a radius capital D. So from the figure, we can see that capital D is equivalent to AS, which is equivalent to BS. And we had studied the fact that arc by radius will be equivalent to theta, that is the angle subtended by the radius at any 2 points on the circle. Here AB can be considered as the arc of the circle, capital D the radius of the circle, and S the center of the circle. So taking the mathematical equation arc by radius is equivalent to theta, we can write small b divided by D is equivalent to theta, or else capital D is equivalent to b divided by theta. D will give you the distance of this planet from the Earth. After determining the distance capital D, the angular diameter of the planet can also be calculated using the method of parallax. Suppose if S is a point of observation on the earth, and let the circle marked in the figure represent a planet, and let AB be the diameter of the planet, and the distance AB is marked by small d, and from the point S we are drawing lines AS and BS. Let alpha be the angle subtended by AS and BS at a point on the earth. Then, according to the equation that we had explained in the previous slide, arc by radius is equivalent to theta. Here, AB can be considered as an arc of a circle and capital D the radius, having center at the point S. Then AB divided by D is equivalent to alpha, or small d divided by capital D is equivalent to alpha. Since capital D is already known to you and angle alpha can be measured, small d, that is diameter of the planet, can be determined by the method of parallax. Hope you have understood the method of parallax for calculating or measuring large distances. Thank you, dears.